Alright, so in this video now, we're going to look at this disease, Xeroderma pigmentosa. Xeroderma pigmentosa, okay? So this one is a likely exam question. This one was given to you by your lecturer particularly, so please know this one very, very well. 90% sure you're seeing it tomorrow. Alright, I've given you guys outline, introduction or definition, the cause, the biochemical basis, clinical manifestation, management. Alright, now as a word of introduction, Xeroderma pigmentosa is what? Autosomal recessive. This disease affects your autosomal gene, okay? Autosomes, not your sex gene. Autosomal gene. Alright, now it is characterized by all those Xeroderma pigmentosa patients. They are sensitive to waiting, high levels of waiting, UV light, leading to waiting skin cancer. So normally, when somebody is exposed to UV light, ultraviolet light, the DNA, yeah, that is your cells in your skin, the DNA present in those cells, it tends to, particularly the pyrimidine nucleotide, they tends to form dimers. They tend to do what? Form dimers. However, when they form this dimer, the cell has the mechanism of correcting this mutation, this dimer formation. The cell has a what? A mechanism, and that is called nucleotide excision repair mechanism. So this repair mechanism will help to repair that damage caused by the waiting ultraviolet light. Then, if this thing is not there, that's when the person will now come down with Xeroderma pigmentosa. Xeroderma pigmentosa. All right, I will say it again. I said that normally, yes, let's say here's the sun. I get my point. Here's the sun. It's giving that waiting UV light, for example. Let's say, for example, I get my point. UV light. Then here's the skin of somebody. Here's the skin. When this UV light get to this skin, it will cause some thiamine. Let's say we have some thiamine here, particularly thiamine nucleotide. Thiamine nucleotide will begin to polymerize together. I get my point. Okay. Once they form this polymerization, for a normal person, this nucleotide excision repair mechanism enzyme will help to correct this thing. It will remove it, and they are going to synthesize a new one there. But in this case now, this enzyme is defective. So even when the person is exposed to UV light, when the person is exposed to UV light, they cannot repair this thing. And if you cannot repair this polymerization of thiamine nucleotide for that particular strand of DNA, it's going to cause high chances that the person will have skin cancer. I get my point. So those people that are normally, once they form this dimer of thiamine, the enzyme, nucleotide excision repair enzyme, will repair it. I get my point. So they're going to repair this mutation caused by the ultraviolet light. However, if this enzyme is defective, then the person is going to be exposed more to likely having a skin cancer. All right, so that's why I said Xeroderma pigmentosa is an autosomal recessive disease characterized by high sensitivity to UV light, leading to skin cancer. What causes it? Lack of this enzyme, nucleotide excision repair enzyme. Nucleotide excision repair enzyme, the enzyme that repair this thing that is usually caused by the ultraviolet light, this mutation caused by the ultraviolet light. If the person lacks this enzyme, if the person lacks this enzyme, the person cannot repair the DNA. So there will be what? So due to a mutation in the gene that code for this enzyme, the person cannot repair the mutation. So the genes are XPA, SPC, and EROCC2. So these are the genes that code for this enzyme. When this gene is defective, I think this virus is exhausted. When this gene is defective, the person cannot what? Synthesize this enzyme, then the person cannot repair the DNA. All right. So what are the biochemical bases? If you notice, look at what I wrote here. I said normally UV light. I'm using the same color. It won't be nice, but let's just proceed. I'll try and manage this one. UV light causes cross-link of between adjacent thiamine bases. That's what I've already explained. There will be cross-link between adjacent thiamine bases. Then, in a particular strand of DNA. So, but this is repaired by by what? Nucleotide excision repair enzyme, NERO. I get my point, as shown below. So let's say this one is a damaged DNA now, for example. You can see that thiamine, I seen it, TT are polymerizing, thiamine are polymerizing. Okay, but when this DNA is damaged by the UV light, what will happen? It will be what? excise, it will be removed by waiting nucleotide excision repair, nucleotide excision repair enzyme. So that's the next thing you see there. So let me just call it on one. So in the first one, what do you see? It will be repaired by nucleotide excision repair. So when that thing is removed, so you can see, okay, this is what I wrote it again. It will be removed by waiting by nucleotide excision repair enzyme. Then what will happen? Once it has been removed, DNA polymerase enzyme will fill it up. We are going to have a refill of that particular place. Remember, this entire place is being removed by this enzyme. So because it has already been mutated, right? So it will be repaired by this enzyme. When this enzyme remove this part that has been damaged by the UV light, DNA polymerase enzyme will synthesize a new one. I get my point. So it will fill it up. It's going to fill it up. Once it fill it up, what then will happen? DNA ligase will now attach it completely. It will seal it. So DNA ligase seals it up. That's what we see here. So this is the repair mechanism. However, if this nucleoside excision repair mechanism, that this enzyme is not able to detect this thing so that they can repair it, if it's not able to detect it, the person will have Xeroderma pigmentosa. Xeroderma pigmentosa. So making the skin to be prone to what? Cancer. Skin will be having some pigments and the like, so it will be subjected to sensitivity to UV light. The person will have UV light sensitivity, high levels of UV light sensitivity. So it will not damage the skin. Then from there, the person can have skin cancer. How do you manage this patient? One, they wear thick clothes, thick clothing. Use of sunscreen also can also be used. Then gene therapy can be used. Okay, so the patient are advised to wear thick clothes, that is to protect them from the ultraviolet light. Then they use sunscreen also, that is glasses. I get my point. Then gene therapy can also be used to repair the gene. Okay, so let's just go over it again. Xeroderma pigmentosa is a genetic condition in which there's lack of the repair enzyme, the enzyme that repair mutation in DNA when the DNA is being damaged by UV light. I get my point. So when the UV light shine on the skin, it will make the skin to the DNA in the skin, in the cell that is in the cell of the skin to polymerize. So particularly the thiamine nucleotide. I get my point. So when they polymerize like this, it will be on a normal day. That's why I said normally. It will be what? Repaired by nucleotide excision repair mechanism. So the enzyme will just come, remove this part. Once you remove it, DNA polymerase will put another one there. DNA ligase will seal it together. Then we have a good functional gene. But in the case whereby we have Xeroderma pigmentosa, this nucleotide excision repair enzyme is defective. So it will make the skin to be prone to cancer due to the ultraviolet light because we can't repair that mutation again. Then from there will be what? Cancer of the skin. Then how do you manage them? Thick clothing, sunscreen, gene therapy. Okay, so if you can write this one, I believe you are good to go for your exam. Please also draw this diagram. Look at it one more time. All right. Okay, thank you.